Hi, let's do a quick review of set notation. We're going to use curly braces to denote a set. The elements will be inside the curly braces. For example, this set A consists of the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Remember, a set has to have unique elements. It cannot have repeated elements. Let's form another set. For example, B. This will be the even numbers from the set A. So that is 2, 4, 6, 8 and 10. Let's form another set, the set C, the set of odd numbers from the set A. 1, 3, 5, 7 and 9. B and C have no elements in common, so they are known as disjoint sets. Okay, let's have a look at the Venn diagram for this. Here we can see the sets B and C. The set B contains the elements 2, 4, 6, 8 and 10. And the set C contains 1, 3, 5, 7 and 9. They have no elements in common. They are disjoint sets. Okay, since every element of B is also an element of A, we say that B is a subset of A. Similarly, every element of C is also an element of A, so we say that C is a subset of A. We can write this another way using the intersection operator, which is an upside down U. The intersection of two sets is the set of elements in both sets. So this becomes B intersection A equals B. It's equivalent to saying B is a subset of A. Similarly, C intersection A equals C, because every element of C is in A. Okay, let's look at the union of two sets now. The union of two sets is the set of elements in either set. So if we write B union C, this will be the even and odd numbers from 1 to 10, which is A. Finally, we look at the subtraction of two sets. A minus B, which we denote with the backslash operator, is the set of elements in A which are not in B. That is, we remove the even numbers, so we are left with the odd numbers, which is the set C. Similarly, A minus C, that is, removing the odd numbers, leaves us with the even numbers, which is the set B. Okay, a couple of points about the subtraction of two sets we had earlier. A backslash B. This is the same as A minus B. And this is the set of elements in A which are not in B. So this is necessarily a subset of A. The second argument doesn't have to be a subset of A. We could have, for example, A minus B with the union some elements not in A, such as 25 and 36. This gives the same result, since the set of elements in A and not in the second set is the same as the set of elements in A and not in B, since 25 and 36 are not in A. Okay, here are some examples of sets you will encounter in mathematics. The first one, Z, the integers. This is one you're very familiar with. Z equals 0, plus or minus 1, plus or minus 2, plus or minus 3, all the integers. This one is very straightforward. The natural numbers n, these are the counting numbers. So from the integers we choose all the positive numbers, 1, 2, 3, etc. The rational numbers, these are one integer divided by another. Just make sure the denominator is not 0. So a divided by b, such that a and b are from the integers, and also b doesn't equal 0. The final one, the empty set, this is a weird one. This is the set with no elements. It's empty. Now if A is a subset of B, This means every element of A is also an element of B. Since the empty set has no elements, this statement applies to the empty set. This means that the empty set is a subset of any set and every set.